Good afternoon and welcome to the ALCTS webinar, Performed Music in BIBFRAME, Enriching the Ontology. This is the third of the six-part webinar series from MARC to BIBFRAME. I'm Eva Sorrell, a member of the ALCTS Continuing Education Committee, and I'll be your host for today's webinar. Our presenter today is Nancy Lorimer. Nancy has nearly 20 years of experience as a music cataloger and now heads the metadata department at Stanford University, where she oversees original cataloging in MARC and MODS and participates in linked data planning. Nancy is a member of the Linked Data for Production project and led the Performed Music Ontology subproject as part of that grant. Nancy is active in the Music Library Association and the Program for Cooperative Cataloging. Her presentation today will describe the Performed Music Ontology and its relationship to BIBFRAME, as well as its relationship to other standards such as RDA and Doremus. A few things to keep in mind for today's presentation. Today's webinar does not have interactive chat capabilities. If you wish to comment on today's presentation using Twitter, you may use the hashtag you see on the screen. We will not be monitoring the Twitter feed. If you have questions for Nancy, please type them into the question box on your screen, and she will answer them as time permits at the end of her presentation. Questions which remain unanswered while we are on the air will be answered offline and the answers sent to all attendees. This webinar is being recorded, and you will receive an email with links to the recording, the presentation slides, and an evaluation within 2 days. There may be a slight delay as I turn the presentation over to Nancy.
So, good morning, greetings from warm and sunny California, or good afternoon, I guess, depending where you are. I'm here to talk to you today about performed music and BIBFRAME. More specifically, I will be introducing an extension to BIBFRAME called the Performed Music Ontology. Developed as part of the Linked Data for Production grant, a Mellon-funded grant led by Stanford University libraries in collaboration with 5 other research libraries, Columbia, Cornell, Harvard, Princeton, and the Library of Congress. While the overall focus of this grant is to lay the groundwork for moving technical services workflows into a linked data environment, a number of the sub-projects concentrate on ontology development for specific domains. Stanford decided to concentrate on performed music. And just as we start, to put a face on the voice, this is me and my contact information. Here, would I also like to point out that for this project that I'm speaking about today, I'm only the coordinator and spokesperson. The work I'm showing today presents the work of many, many people, the community of the LD4P grant, and especially the Performed Music Ontology team. Now, a brief overview of what we'll cover today. First, we'll step back a bit and talk about cataloging performed music in MARC, particularly the issues of relationships and compilations and what is lacking here. Then we'll take a quick look at the promises of linked data and why we just decided to extend BIBFRAME rather than some other ontology. After that, I will move into the main part of this talk, the Performed Music Ontology, or PMO as I'll usually call it. I'll discuss the collection of use cases in preparation for creation of the extension, along with some specific examples, and then the primary components that make up the PMO extension to BIBFRAME. Finally, I'll speak about current work being done on the ontology and work needed in the near future. So why is linked data of particular interest to catalogers of performed music? Let's take a look at the current state of a sound recording record in MARC. The record in front of you, divided into 2, of course, to fit on the screen, is fairly typical. A catalog record for a disc contains a compact disc containing 4 pieces by the composer Philip Glass. I want to point out that all the information in this BIB record to point out to you all the information in this BIB record about a single work here, an arranged version of the etude number 2. Now, the first time the word etude appears in the record is in the contents notes, and of course it's etudes with an S, as you can see in the highlighted in red. To find the arrangement of number 2, you need to look past a few other pieces of text to here, where you also learn that this number 2 was reworked by Christian Badzura, whatever reworked means. If you move a couple notes up in the record, you learn that this version of the Etude number 2 and another glass work in this compilation were recomposed for piano quintet. Because of this, you now know that the instrumentation, this instrumentation and not the one above it, applies to these two works. Now just remember, you figured all that out by reading the bibliographic record and reading it backwards at that. All the information and the implied and stated relationships of work to work component to medium of performance, an arranger, composer, is scattered throughout the record here. Only by reading the entire bibliographic record can it be brought together. To continue to the controlled access points, we can see that there are the relations recorded, subjects and genres, the controlled name of the composer of the expression, and the relationship of the whole compilation and the individual work. Again, all these relationships have to be inferred by the person reading the record. They're not linked to each other in any way, and they are not machine readable for the most part. Now, just to continue, or perhaps belabor the point, here the 511 gives the names and instruments of the performers in the compilation. We can only infer that everyone on the list is involved in the performance of our particular etude, since it is a piano quintet and our performers are listed as a pianist and 4 string players. Besides the 511, the individual performers are also given in controlled 700 fields, where their instruments are generalized just to being instrumentalists. And then we have also the string quartet below. If you had started with those access points, the only way to know that those 4 of those performers in the access points above are actually members of the Sigi string quartet is to go right back to that 511 note. Once again, it's necessary to scan the entire record to get this information. It is scattered, it comes in free text or controlled strings, and tends to repeat itself with different granularity and vocabulary. The only thing that really relates them is that they are part of a single database record. Relationships are either implied or given as text strings. None of this can be read by a machine to put all this together. It requires a human reader, and a fairly patient one at that. So to sum up the issues with MARC, data elements are linked together by the context of the database record, and usually nothing else. Identifiers or access points are text strings, and relationships are expressed in free text notes or controlled text strings requiring human interpretation. Because of all this, the data is not machine readable particularly, or machine actionable. And so we turn to linked data. Whereas in MARC, we rely on the database record structure. In linked data, data elements are linked together as individual independent statements that are not tied to a record format. That makes them reusable in other contexts and easily reconciled. And whereas in MARC identifiers are text strings, in linked data, identifiers are URIs, resulting in disambiguated identifiers that do not rely on unique text strings. Likewise, relationships in RDF, the basis of much linked data, are expressed as semantic triples in the form of URIs rather than text strings or notes. Because of this, the triples are machine readable and machine actionable. Because of this built-in ability of linked data to semantically link individual relationships among data elements, it has great potential to improve the way music, and particularly compilations of music, are presented in our catalogs. But to do that, we need to model all those data elements, and that is the role of an ontology, such as BIBFRAME. So why use BIBFRAME to provide metadata for performed music? The usual context of this question amongst catalogers is in reference to RDA. If we are using the RDA cataloging standard, why not use the RDA ontology? That is a perfectly reasonable question. And since we are talking about music, there are also already some other music ontologies available out there. The music ontology, which has been around for several years and is even based on Ferber and is the basis of music brains. And lately, the Bibliothèque nationale de France, Radio France, and the Philharmonie Française have been developing Doremus based on Ferber OO and CDOC CRM. So why not use them? Well, in using BIBFRAME as the basis for our work, we were choosing an ontology that potentially works with multiple content standards, or even a lack of a content standard, while still being capable of providing a shared cataloging environment. While we use RDA when we are cataloging music currently, others may not do so, and we want to be able to have easy interoperability despite these differences. So that is one reason why we chose BIBFRAME, say, over RDA. Our other two ontologies have similar difficulties in use, being intended only for music materials, such as in the music ontology, or based on more complex data models, such as Ferber-OO with Lorimer, and they run the risk of being not compatible with, or at least too separate from the modeling for all our other resources and libraries. We want them all to interact. So in sum, we chose BIBFRAME because it is for all types of library materials, not just sound recordings. It is compatible with a variety of cataloging content standards, including no standard at all. And most importantly, it is customizable while still providing a common framework. The drawback, however, is that we suspected, well, really we knew, that BIBFRAME does not include all the necessary relationships to best express performed music resources. On the other hand, we know that this is intentional in BIBFRAME development and that it was intended that specialist communities extend it as needed. So that is why we decided on a formal extension to the core BIBFRAME ontology. So now we will move on to our main topic of our webinar, our extension to BIBFRAME, the Performed Music Ontology, or as I said, PMO. The primary goal of our project was to develop a performed music extension to BIBFRAME, covering description of recorded sound from wire recordings to streamed audio to music video. Using BIBFRAME as a core ontology, we developed domain-specific vocabularies, enhancements, and extensions to BIBFRAME for use by the library community as an initial basis for a common standard. In doing this, we are hoping to explore models whereby similar standards can be created, endorsed, and most importantly, maintained by the library community. Clearly, the ontology will change and develop over time, but we hope to create here a strong basis for its development. Because we were emphasizing this particular domain, our community was of paramount importance to this project. As I've said before, we can develop a beautiful ontology, but it is of no use if it is not acceptable to the domain community who might use it. And of course, all the domain experts are to be found primarily in those same communities, and it would be detrimental not to make use of that expertise. Stanford therefore partnered with some domain communities, the Music Library Association, the Association of Recorded Sound Collections, hereafter ARSC and MLA, and the Library of Congress, as well as keeping the program for cooperative cataloging in the loop with us. Members of the ontology group listed here represented all these communities. In addition to our community representatives, and to make sure we did not go too far down a performed music silo, the PMO team also included people from Stanford, our audiovisual cataloger, our metadata coordinator, and our humanities metadata librarian, all of whom had some data modeling experience. So, one of the first things our group did was go to the Music Library Association and ARSC and collect use cases. Use cases, or user stories, are collected examples of questions users ask of data in a particular area and how they intend to use that data. In turn, this information both validates our need for an extension, that is, that there are use cases but not covered by the primary ontology, and informs our decisions in creating the extension. So here is an example of a reference question once asked to me that was formed into a use case, as you see on your screen here. It says, what is the music played at the final wedding in the movie 4 Weddings and a Funeral? I want to use it at my wedding. Now, this really was a real reference question I once got. It seems a simple question in a way, and wedding music always comes up in music reference, as you music librarians will know. But think of how this data would need to be recorded if it was to be in the catalog, the information about this was to be in the catalog. The person is asking for the name of a musical work being performed as part of a larger work, a movie, and it gets even more complicated when, as we realized at the time, that the work is not being performed in its original instrumentation, but it is an arrangement for organ, as is fairly typical with wedding music. Even more so, in that work in question, commonly known as the Entrance of Queen of Sheba, it's part of a larger work, Solomon, by Handel. So to fulfill this as a use case then, we need to be able to link a portion of a musical work to a performance in a larger non-musical work. As an aside, this piece also occurs in several different scenarios. It's a very popular work. And I recognized it at the time eventually because it used to be the theme music for the 6 p.m. radio broadcast of the Canadian Broadcasting Corporation way back when. We collected use cases like this and various requirements from catalogers, from archivists, from reference librarians, from music bibliographers, and from some users, drawing on their long experience in working with music resource users and reference questions. We collected a few hundred of them. Most, however, could be clustered into a few areas: use cases surrounding persons, surrounding works, surrounding medium of performance, and surrounding events. The ones I will mention here are just examples from the set and not the entirety, don't worry. So first, persons. First, we have a person as an agent, usually a performer or a writer, but also a manager, a sound engineer, and how they are associated with a particular work or a particular event. This is quite familiar from the work perspective for all of us catalogers, but less so from the event perspective. Second, users wanted to know which performer performed on which instrument or voice, and this is a very long wanted relationship that we can only now relate in a note, as you saw in that Philip Glass example. This can be expanded further even now to want to know that that performer played a particular instrument in a particular work at a particular event. And even to extend further, they want to find out if the performer performed as a member of a particular musical group in that particular event. Just to understand this last, we have to remember that many performers play multiple instruments and/or sing, and that over their career they may belong to multiple musical groups, often at the same time. Our next broad area for use cases were use cases around works. For the work expression-heavy music world, there were, of course, multiple use cases referring to works, from simply expressing all the possible relationships between works, which are immense, expressions and instances, to describing works within works, whether that larger work is another musical work or a non-musical work, such as a film, which we mentioned before, or part of an event, and how to describe and find works such as medleys and computer-generated works that in the first case include bits of multiple other works, and in the second case might be described as a musical work or just an algorithm. There was also a need to find music works at different levels of granularity than we do now. That is, say, of the take level. The take level is not done at this time. Other use cases involve questions about how to express and query various manipulations of works beyond the medley idea, and they're listed there. And also, strangely, connecting a musical work to an incipit of that work, that is the beginning little tune, and also things such as social things, such as the publishing and sales history. So, for events are interesting because they've always lurked in music cataloging, in the description of a performance, in the capture data as it's known, but we have never concentrated on them that much as in description. We did get a number of use cases centered around events though. Most simply, people wanted to be able to query by types of events and by basic descriptive data about events, such as date and place, going into detail about the details about a recording session or a concert. So an events within events. In returning to performers again, users wanted to find if someone performed on a particular instrument in a particular group at a particular performance. For instance, especially if one performer actually replaced another in a musical group at one performance in a concert series. Next, we had some use cases around medium of performance. Now, this is a topic that has been something of an obsession for music catalogers over the last several years, since the introduction of the 382 field in MARC. Our use cases here are more requirements and primarily reflect what can be recorded in the 382 field currently, what doesn't work well in the 382, and what simply cannot be expressed in MARC. One of the most important use cases was to be able to describe a medium of performance as is declared in a score or by a composer in some other manner, with the medium of performance actually not used in a performance. For instance, a work composed for piano that is performed on a harpsichord, or a work for a bassoon quartet, which is performed by eight bassoon players. And yes, I have done that. One other requirement that looms large amongst music users and catalogers is to be able to express sequence, the order in which something appears, whether it is the order of discs in a set, tracks on a disc, works in an album, or events within an event. While seemingly obvious, this is often difficult to accomplish in the linked data universe, where data consists primarily of individual statements that may be reused in various situations. Now that we had our use cases and requirements, it was time to look at BIBFRAME and how it could work with Performed Music. But first, a very short refresher to BIBFRAME. The Library of Congress initiated the development of BIBFRAME as a successor to the MARC format. Notice I don't say replacement, but successor. BIBFRAME is designed to enable the discovery of bibliographic information on the web and in the broader network world. It utilizes Resource Description Framework, or RDF, a data model consisting of statements expressed in triples. So in RDF, every entity, such as the author, subject, place, ideally should have a corresponding unique identifier in the form of a URI. Thus, every entity and every relationship can be expressed as URI, not a text string. The text string itself actually can change, but the link will remain. BIBFRAME is loosely based on the functional requirements of bibliographic records, or FRBR, and is centered on three primary entities: works, instances, and items, as you see in the blue up here on your screen. Other entities are defined in relation to one of those entities. Works are basically equivalent to the FRBR expression loosely, whilst instances are equivalent to the FRBR manifestation. There is no equivalent to the FRBR work in the BIBFRAME conceptual model, but as we will see later, it can be expressed in many ways. One aspect of BIBFRAME that moves beyond FRBR is the addition of the BF event, which became an independent class with the publication of BIBFRAME 2.0. The BIBFRAME is intended as a lightweight framework, not a fully developed ontology. To use BIBFRAME, the framework requires the filling out of vocabularies and relationships, either drawing on other ontologies or developing new subclasses or vocabularies within. This is what we are doing in the Performed Music Ontology project, extending its vocabularies and classes and relationships to better express music data and fulfill our user needs according to our collected use cases. Beyond this, we will also require an application profile, which defines all the outside vocabularies and relationships from other sources that we use, and something I will mention briefly further on. Now, to look at BIBFRAME in relation to Performed Music use cases. When we take our use cases for Performed Music into account, a few adjustments to the BIBFRAME model seem necessary, if only an emphasis. Events, that circle on the top right, becomes as important as works, and agents, the circle at the top, loom much larger since there are just so many of them in a musical recording. Finally, there are all those music instruments and voices, which we gather under the term medium of performance, which deserves its own circle in the schematic pictured here with the musical notes. Here's a somewhat tidier way of mapping that top part. That group of four circles at the top, work, medium of performance, performer, and event, is what's most important to the Performed Music Ontology. Of course, those relationships are a bit more complicated than that. The relationship arrows really go all the way around, always, not just in a circle, and performers have that relationship with performing groups. And then there are works, which in music are very complex and layered in their relationships. The ones we have concentrated on in PMO are aggregating works or compilations, and work expressions, such as multiple recordings of the same work and how they relate to one another. So now it's time to dive deeper in, starting with events. In basic BIBFRAME, events are modeled very simply with the class BF event, combined with the subclasses, with the properties BF event content and BF event content of, which connect events to works. For actual use, however, this is rather generic, and music people particularly are interested in types of events that are recorded or performed. So one of our first tasks was simply to subclass BF event to describe various types of musical or partially musical events. We created 9 subclasses in PMO, 2 of which also have subclasses of PMO Performance and PMO Concert. Many of these subclasses are too specialized for a general ontology such as BIBFRAME, but others could apply to other resources outside of music easily as well, such as a ceremony or performance even. We tried to keep the definitions of these as general as possible to include various types of content. We also brought in some added properties. The 2 most important for PMO purposes are subclasses of BF event content and BF event content of. So we have PMO has recording, PMO recording of, PMO performance of, and PMO has performance. These 2 pairs of properties allow us to model the relationships between performances, composed works, and recordings. We also added 4 other properties that relate events to works, these 4 at the bottom, though we count these as possibly temporary in PMO, given that they can apply to really any type of event or work, not just musical ones. Now, while more complex than what we've had before, this is still a fairly simple modeling of an event. Other ontologies, Ferber OO, perhaps notoriously so, but also the music ontology, have more complex modelings of events and the relationships to one another and to works. Our team, however, felt that we should not be trying to duplicate this complexity, but to retain a more generalized framework in the spirit of BIBFRAME. However, acknowledging that some users might need that more complex structuring and to begin to find links with outside ontologies to our own, the team formally stated that in the modeling events that a PMO performance is also a subclass of Ferber performance as well as a BIBFRAME event. Because of this, a user PMO can move fairly easily into the Ferber OO/Doremus event model rather than using the PMO model if they need to. To illustrate that modeling, here's a diagram showing how a recording session is modeled in PMO based on in PMO. At the left, we have the class PMO recording session, which represents the overall event that's the most common source of sound recordings. Recording session is made up of a number of performances. In this particular recording session, we have 3 performances, song 1 at the top, song 2 in the middle, and a different take of song 2 at the bottom. The performances are connected to the recording session with the property BF has part. In turn, the performances are recorded, becoming BF audio works, linked by the property PMO has recording. Finally, 2 of the individual recordings, we only took 1 take of song 2, are instantiated in a BF instance as part of a compilation, which I'm not really modeling here. The unused take is left there as a BF audio, a work, but with no known instance. Now moving on to medium of performance, an area which had, as we know, there are a great many user requirements. Here are the classes included in core BIBFRAME for medium of performance. They do exist. There is a general music medium, which is defined as a summary statement of the medium of the musical work, or in other words, basically a label that gives the instrumentation as a string. Then the instruments can be given separately in the 3 other classes, BF music instrument, BF music voice, BF music ensemble. What is somewhat limiting about these is that the only place the instruments come together is in that string of music medium. Otherwise, they are all separate statements. Also, if you were to search for instruments, you would have to search separately for ensembles, for voices, for instruments. Our group decided that we would start all over again with the goal of making medium of performance a fully modeled ontology within an ontology that could be used with BIBFRAME, but also any other ontology. To do this, we had to do away with the original classes and created, oops, I just got lost. To do this, we had to do away with the original classes and created our own. Now, I'm not going to go through each class individually, but I would like to point out the first 3, declared medium, PMO performed medium, and PMO medium part. The first two, declared and performed medium, act as primary nodes for medium of performance statements. So all the other statements hang off one of these two classes. Declared medium is the medium of performance as stated on a score in the table of contents or recording or by a composer. Performed medium, on the other hand, gives the medium of performance from an actual performance that is recorded. And as again, this may be different. A sonata might have a declared medium of harpsichord, a performed medium of piano. And again, our bassoon quartet played by an octet. Medium part divides these larger nodes into separate instrument or ensemble groups. A string quartet, for instance, would have 3 medium parts, one for the violins, one for the viola, and one for the cello. The actual instrument or voice is linked to the medium part, which may also have a medium part type, which gives sort of a role of the instrument, and music part, which will give, where you can state such things as violin 1 and violin 2. Similarly, these are the properties from core BIBFRAME for medium of performance on the left. Here I just want to mention these highlighted ones. These 5 data properties replace the generic BF count to give various counts of instruments, ensembles, performers, etc. required for medium of performance. In other words, so a string quartet would have 2 violins. A special interest here perhaps is the count for the number of hands, as in a piano 4 hands work, and the differentiation between a required performer count and the actual performer count. So I realize, particularly with medium of performance, my just reeling off what the classes do doesn't really give you a good picture. So here again is an example, a model of a performance for solo bassoon and orchestra in a sound recording. The BF audio has a PMO performed medium linked by the property has medium. You can see we have 2 counts there, which are somewhat abbreviated on there. One is what we call the distinct part count, which is for individual instruments, and an ensemble count. So each of these is one for the bassoon and one for the orchestra. The PMO performed medium has 2 PMO medium parts. Again, one would be where the bassoon is and one for the orchestra. Each again has counts, an ensemble count for the orchestra, and both a distinct part count and a performer count, meaning the actual number of performers for the bassoon one. Each medium apart, of course, is associated with a distinct medium of performance. Finally, you can also see at the top there, the top circle, that it has the PMO medium part for the bassoon has a medium part type of solo, and this comes from a controlled vocabulary we developed for use with PMO. Now, while that medium of performance modeling brings together all the instrumentation that you gather, it does not actually link a medium of performance to its performer, which was, of course, another primary use case for our group. To do this, we needed to turn to BF contribution, the class by which agents and their roles are linked to works in BIBFRAME. PMO also allows PMO medium of performance and its subclasses and PMO medium part type and music part to be linked to the BIBFRAME contribution. This allows us to directly state that a performer performs on a specific instrument and plays a specific part, such as violin 1 or violin 2, and a role, such as a solo role in a recording. We also added one other class, PMO dramatic role, which associates a performer with a dramatic role, such as a role in an opera, through BF contribution yet again. So here's a diagram showing how the linking works. At the bottom, we have our work and medium of performance. Above BF audio, we have BF contribution. And with those long arcs in between my 2 circles there, we have has music part, which goes down to part of violin 1, and the musical instrument violin. So here we know that this person in Irvine Arditi is playing the violin 1 part. That, of course, was a modeling of a single instrument. It can get more complicated than that very quickly. This is a partial model of a performance by the RDD quartet. In the center, we have a medium of performance, and here we give it in two alternate ways, one as an ensemble and one with the individual instruments. This was yet another use case. I will point out again, the individual instruments, I only have the violins, not the viola and cello. Through BF contribution, the two violinists of the quartet, Irvin Arditi and Lennox McKenzie, are named at the top of the diagram, as well as the string quartet name, RDD Quartet, at the bottom. And all are connected to their mediums and the two performers to their requisite parts of violin 1 and violin 2 in the quartet. Again, I only included the violins here for obvious reasons. This is complicated enough to read without adding the viola cello as a full modeling would require. The last major area the PMO team explored was works. BIBFRAME defines works in relation to instances, but there is very little to connect different works, or what would in RDA be described as expressions of the same works. There is also no obvious way to model compilations, publications containing multiple individual works. Both of these relationships are of major importance in the cataloging of performed music. Unlike most formats, compilations tend to be the dominant mode of publication, and multiple expressions of the same work are extremely common. Think of the number of times Beethoven's Fifth Symphony has been recorded, and then realize that every new performance captured as a recording is a new BIBFRAME work. PMO took on works very reluctantly, since there was a feeling that this was a much bigger than our own ontology and that it should be a part of the larger community. But given that it is impossible to avoid these issues in cataloging sound recordings, we felt we needed to present something. We restricted our work to providing a possible solution for bringing works together multiple expressions, in this case, some BF works, together, and B, to provide a provisional solution for expressing compilations in BIBFRAME. We present these solutions as a step towards a broader discussion of these issues among the greater BIBFRAME community as it develops. They are by no means complete. For our first problem, expression problem, let's look at a concrete example. And here we have Kaya Sarriaho's Amour de Loin, opera which was premiered in August 2000. Besides the world premiere itself at the top, there is also one other live performance and two recording sessions of the opera that I know of, shown here on the left. These would all be BIBFRAME events of one sort or another, performances, first performance, and recording sessions. The world premiere performance has no known recording, but the other performance was recorded and published as a video, a BIBFRAME video, as we see here. The two recording sessions were combined to create one audio recording, a BF audio. To these two known audio and video works, we can also add two notated music works, the full score and the vocal score derived from a related, and the vocal score derived from it. We also have a related work, Reflet sur l'amour de loin, and the separately published libretto and its translation. So you can immediately see the problem. Well, these are all events or works based on or related to l'amour de loin. There is nothing in the BIBFRAME model that brings them all together. You could possibly separately link every single one of them to each other with a related to type of property, but that could be very work intensive and not particularly expressive. There should be a better solution. The easiest way, of course, to resolve this problem is to look at Ferber or LRM and bring back what amounts to the work expression distinction, with a BIBFRAME work taking the place of a Ferber work, and BF audio, video, etc., assuming the place of a Ferber expression. If we bring that concept of a Ferber-like work back, we can connect all these works and events together. The performances and recording sessions are linked by PMO has performance to the BIBFRAME work. The video, audio, and notated music works by BF has expression, and that leaves the related works to be connected by other properties. probably ones taken from the RDA registry. There is still, of course, a direct link from the performance and recording sessions to the specific BF video and BF audio works that are recorded. So now we have this BIBFRAME, generic BIBFRAME work. So now, while the Thurber-like work is often necessary for works with multiple recordings, arrangements, and means of expression, unlike in Thurber, the PMO, the BIBFRAME, BF work / BF audio distinction is not mandatory. If you don't need it, you don't need to use it. Here's a more schematic diagram showing the generic BIBFRAME work linking to BIBFRAME audio works. Here each with 3 instances, just to look pretty. This link is much more expressive than a simple related to relationship, with the added benefit that work information doesn't necessarily have to be repeated for each expression. Here on the right, the diagram is expanded to include the relationship with a performance, showing that a BF audio usually combines an event and a pre-existing work. There may be some exceptions to that. So that was expressions, but now we turn to compilations. As a group, PMO members talked about works and compilations for well over a year. And compilations are tough to model, which is perhaps why no one ever seems to get to them. In the end, a few of us at Stanford got together to develop a very basic working model. Though we had experimented with some other interesting models over the year, we wanted something that would be generally acceptable in the whole library world, not just as part of PMO. So in the end, we returned to the IFLA LRM model and the very, very basic compilation model provided there, which is what you see on the left of your screen. Very loosely, the LRM model recognizes the aggregating expression to be the locus of all aggregation and compilations, which in turn creates an aggregate work. The expressions of each individual work are aggregated into, but are not part of that aggregating expression. It is not a whole-part relationship. From this, we developed our basic model for compilations, which looks remarkably similar, except for one thing, that circled layer there. This is an additional layer, what we call the aggregated expression. So a primary issue with music expressions is that they might appear in multiple compilations. And in those compilations, they might appear in a different order or as a different track number or track numbers. And again, this sequencing of works on an album was extremely important use case for us. So for the LRM model to actually work for us, we had to develop it so that each time an expression of a work, or a BF audio if you wish in this case, appears in a new compilation, that has to be a new expression every time, the aggregated expression, even if it is otherwise exactly the same as an independent work or expression. Only in that way can we add individual properties, such as order, that apply within that compilation. Now, though that kind of works, we did find it a bit strange to add such properties as track number to an expression. It seemed much more an instance level property. Also, it seemed that there are often relationships between individual instances in the compilation and instances in other compilations, such as the case of sampler recordings. Because of these use cases, we also developed a second model, which is not fully written out here, but close. One in which the aggregation takes place primarily at the instance or manifestation level. In this model, the compilation has an aggregating instance that comes from the aggregating expression, which contains individual instances of the individual expressions of the work. The benefit of this model is that a property such as a track number can be associated with that particular individual expression instance, rather than the expression, the aggregating expression, which seems somewhat more logical here. It also allows for our properties to be at the instance level and allow for relationships between the individual instances and ones in other compilations. The drawback of this model is primarily that it yet again extends the basic work instance item model of BIBFRAME, that's what seems so simple. We also don't know if it's compatible with LRM, but suspect maybe not. Further, a series of papers further describing how we modeled works is forthcoming with all these models presented. Part of it is out, not all of it. We hope that this will start a conversation about how we'll be modeling works and compilations moving forward and help look at some of the difficulties we've been facing. So that has been a very quick look at the primary modeling done in PMO. You can be relieved it's done now. It can look very complex, and in many ways it is, but it doesn't have to look that way to those doing metadata creation. While we have not yet done a huge amount of metadata creation in PMO thus far, we are developing templates to really work it, and using template creators from 2 different sources. And I just want to give you a quick look. First, we are working with the Library of Congress BIBFRAME editor. Here is a prototype profile of a PMO as done in the editor. Here showing a portion of a template covering a performance and a work. And we are close to making a version available for users outside of Stanford fairly soon once we've fixed some local bugs in our system. The main thing to notice here is that the template offers human-oriented guidance for the underlying modeling structure, here in terms of RDA. In fact, it links directly to RDA. You do not see the RDF or even BIBFRAME at all in this template. Here is another template we are working on called CEDAR, developed by the Stanford Bioinformatics Lab with a grant from the National Institutes for Health. Again, I'm only showing a portion of the template, obviously, for PMO, in this case for medium of performance. You can also see there on the bottom a pull-down menu for the vocabulary for a medium part type, all of which is controlled vocabulary within the system. While not originally developed with library data in mind, CEDAR has a potential to be very flexible and more powerful than the LT editor. For one, the template is directly linked to the ontology you are using. Template fields and vocabularies link directly to their respective ontologies when in the process of template creation and can access the class subclass structure of that ontology. The LC editor, on the other hand, requires the template creator to manually type in the various URIs for the ontology. So there are benefits to CEDAR, but we are working on full templates for both of these editors. While neither templates require you to read the code, in both you have the option to do so. Here's a sample output here in Turtle, but also available variably in JSON LD, N triples, and or RDF XML, depending on your local implementation. This is what is submitted to the data store and reconciled with other data entries, and then theoretically displayed in a human-friendly way in our catalogs and discovery layers. So this we have not yet attempted to do with PMO. Stanford has a prototype using blacklight for discovery, but it is only for books and very, very limited in scope. This is something we intend to work on in the next linked data for production grant, if we get it, developing blacklight into at least a partially linked data enabled discovery layer. PMO will be part of that development. Okay, and I know we've talked a lot about complex things and it's time's getting on. I've mentioned from time to time in this talk that there are a number of papers explaining the modeling and the concepts I've shown you in much further detail. There are several ways of accessing these papers as well as the ontology itself. First and most basic, PMO resides in GitHub, the software development platform which also stores ontologies. This is where you can find the raw code for PMO as well as the modeling papers as they are finalized. This is also where you want to go to link to or download the ontology and to access related vocabularies and documentation. Other useful materials such as mapping back to core BIBFRAME and examples are being added as they are created. PMO also appears more formally and in a more human-friendly format in BiblioPortal, an extension of BioPortal, the Stanford Bioinformatics Lab ontology portal, and in BioPortal itself. You can see here that it provides a more formal description, context, and even metrics. The ontology itself comes directly from the GitHub repository and updated along with it. Other interesting additions given by BiblioPortal include an initial list of projects using the ontology. In this case, the Cornell Hip Hop project is listed. It also adds some mappings to other ontologies that were automatically created, these mappings, by BiblioPortal. While some of these should probably be taken with a grain of salt, it is a great first stop for mapping possibilities for people working on them. Finally, for information about the whole PMO project in general, you can go to the Linked Data for Production public wiki, which gives a formal description of the project, a list of current activities and completed work, the team members, and links to various presentations given about the ontology over the last 2 years. It is interesting to look at these presentations to see how our modeling efforts have changed over time as we became more adept at modeling and also more adept at diagramming. URLs for all these resources are given at the end of this slide set. So before we end, a few thoughts on lessons learned in working on the ontology over the last couple of years. First, ontology development takes a lot more time than one might think. Originally, we had hoped to finish PMO within a year, but despite intensive weekly meetings by teleconference and a 2-day in-person working meeting, it took much longer, and there are still a few loose ends to tie up. Second, we found the intensity of the work and skill development it required was suited to a small group work. We had initially hoped to involve a larger contingent of people from MLA and ARC in ontology development beyond our core group, but except for the invaluable gathering of use cases and medium of performance requirements, this did not really work so well. We are still working on that aspect, as members of MLA are currently critiquing the ontology. A final lesson, and perhaps not surprising to catalogers out there, we found the best way to learn ontology work was to do it. We had a lot of new skills to learn: ontology design, data modeling, conceptual understanding of our domain, and simply reading RDS, something I think Joyce mentioned last week in her webinar. And much of it we learned by doing. Reading in classes can take you only so far. And as a final slide, where are we going from here? Well, currently, the Music Library Association Linked Data Working Group, known as Ludwig, is looking at our ontology and talking about it and critiquing it. We're developing templates in the LC editor and Cedar editor for data entry and intend to do some data entry soon. And I'm also completing the modeling papers. In the near future, we hope to do work with MLA to find a way to do practical testing. This may be part of the next Linked Data for Production grant. We also want to work with the Library of Congress to introduce testing of PMO there, which they intend to do. We will then want to publish the ontology formally, either at a Stanford, through Stanford, or with the Library of Congress itself. Finally, it would be beautiful if we could do some mapping projects with Lorimer and the Music Ontology. And hopefully the Music Library Association will be creating an application profile for use of BIBFRAME with RDA. That is, adding various vocabularies we would use, properties from RDA, and so forth and so on. And here are those resource URLs I promised you, and that is the end of my webinar. Thank you. And then we can take questions, I guess, now, anytime.
Yeah, remember, if you have questions for Nancy, please type them into the question box on your screen. Nancy, since many libraries are working with shrinking budgets, how much time and staffing are you dedicating both to the PMO and BIBFRAME on a larger scale at your library?
Ooh, that's a difficult question because it's actually just part of our jobs here to do this. Let's see, probably for me, I spend probably 30 to 40% of my time working on the grant work one way or another. It has its ups and downs. Of course, there are days I do absolutely nothing. But of my staff and other staff in the library, such as Kevin, who is the cataloger in the music library, and so forth. As I said, we met 1 hour a week during the year, and they did work on their own in various amounts over that time. It's hard to say exactly how much time we were spending on it, but as I say, it's actually part of our job descriptions to do it. So.
Okay, that's interesting. Okay, and one of the things you displayed about that was for a GitHub, which seems more systems related. How much technical experience would you need to download and use what's there?
To simply download the ontology onto your laptop or something like that, it's extremely easy. I mean, it helps to have someone give you a little tour of GitHub, if you have a systems librarian, they will know how to use it. So I learned everything I know about GitHub from Josh, one of our systems librarians who's working on this project with us.
Okay. In BIBFRAME, BF event is defined as being documented by a resource. In your example, the world premiere of Amour de Loin, I might have botched that pronunciation, but was not documented by a resource.
It's Love from Afar, its other name.
Okay. Was not documented by a resource, so would not meet the definition of a BF event. How would you handle this scenario?
Well, that's a good question. I would probably ask the Library of Congress to change the definition of BF event. We have asked them to do various changes of definitions for us. Generally, in cataloging, you probably would not most of the time be actually cataloging an event that does not have a resource, because you are generally cataloging the resource. This basically is something that goes outside general cataloging. And I think the BF event, as it is currently defined, is thinking of events completely in the cataloging world. However, if you actually are recording an entire, doing the metadata for an entire recording session, there will be parts of it that do not make it into a recording. And so there will be ones that are left behind. And it's also with the Amour de Loin, as we said, that world premiere recording is interesting to note, and often is noted in bibliographic records, but we don't have an actual recording of it.
Okay. What place does sound mixing have in the ontology? Is it an event, a contribution, something else?
At the moment, I would say it's a contribution. That might be a simple answer, but I don't think I'll go into it further.
Okay, and we probably just have time for one more question. The development of PMO almost seems too granular, and do you think this will be very practical for metadata creation, considering how much time it will be spent on creating one resource?
Unless you are actually cataloging at the take level, which we don't do in MARC at the moment, but for the most part, but many would like to do, it's actually not that much more granular than MARC is right now. The only part might be in medium of performance. It seems very granular, but it is actually slightly less granular than the 382 field is in MARC. It doesn't quite get everything in there. Just because you actually have all these options doesn't, of course, necessarily mean you use them. And that's what an application profile would do, especially one for the Program for Cooperative Cataloging. Say, you would actually state how granular you are going to go with your cataloging.
Okay, thank you.
If I could just add, that is the nice thing about it. It's one thing we really tried to do, is make what we sort of thought of as an accordion, that you could do something very small and tight, or you could do something very big. But that small and tight, because it's linked data, other people could add information to it as you went along.
Okay. Thank you. Remember that if you have any additional questions, go ahead and type them in right now, and Nancy will be able to answer them off air and send them out. So I want to say thank you to Nancy for your engaging presentation on Performed Music Ontology and BIBFRAME. Thank you to all our attendees. We hope you have found today's session useful. You will soon receive a short online evaluation form along with links to today's recording and slides. Please take a few minutes to respond to the questions and return the form to us. Your comments are very valuable and help the ALCTS committee improve its webinars and help plan future events. ALCTS now offers certificates of attendance to webinar participants. More information on this will be included in the email you receive. Information about all ALCTS webinars can be found on the ALCTS homepage. Please check out our web courses and upcoming e-forms. Suggestions for webinars and other CE opportunities are welcome at any time. Please contact any member of the ALCTS CE committee or submit a proposal for a webinar using the online form on the ALCTS web page under Online Learning. I would like to thank Catherine Balick and Mary Ryder for providing technical support for today's webinar. The support they and their colleagues on the Technical Support Subcommittee provide make it possible for us to present these webinars smoothly. Thank you for joining us this afternoon, and we hope you will participate in other ALCTS continuing education events again in the future.